We have a full room here at the San Francisco Human Longevity Clinic, and I know we have a full slate of folks that have joined us by webinar. My name is David Caro. I'm our company's president. I recognize and know many of you in the room and on the webinar. It is my great distinct privilege to introduce Dr. Eric Verdin, who's become a friend and of course a colleague as well. And I'm obligated to read his extensive credentials, but then I have something more personal to say. So Dr. Eric Verdin is the president and chief executive officer of the Buck Institute for Research on Aging. A native of Belgium, Dr. Verdin received his doctorate of medicine and completed additional clinical and research training at Harvard Medical School. He has held faculty positions at the University of Brussels, the National Institutes of Health, and the Picauer Institute for Medical Research. He is also professor of medicine at the University of California, San Francisco. Dr. Verdin joined the Buck in 2016 after spending the previous 20 years as a senior investigator at the famous Gladstone Institute, where he served as associate director from 2004 to 2016. Now, I want to just add to that something somewhat personal. We all know that in the longevity space, there's a lot of noise, and we have to filter through that noise. I would also say that the longevity space in general is somewhat artisanal. And of course, we lead with our science, but every time I meet and engage with Eric, I learn something. And so we were giving talks together in Monaco. And we're sitting there and I was drinking my orange juice and there were some questions in the audience about carbs and intermittent fasting and is sugar the new toxic evil? And Eric had this just really insightful comment, which is, well, the French have figured this out for years and centuries, which is that if you're going to have a baguette, you don't just have a baguette, you have baguette with butter, and butter has fat and protein. So your body, if it's going to see carbs and sugar, mix it with a little protein and fat, and it really completely reorganizes how your body sees the carbs and the sugar. So just something like that, just a small little anecdote in this sort of artisanal learning center can really make an impact. So with that, Dr. Eric Verdin, and thank you as always. I always learn something from you. Thank you.
All right. Good evening, everyone. Thank you for being here. And it's both an honor and a privilege to be here and to address all of you as well as the online audience. I'm blessed in terms of the job that I have, working both as a physician at the interface of the science of aging, but also, really trying to bring all this knowledge to the public has really become something that I did not expect I would enjoy. But these types of evenings are actually quite often what make my day. And so what I'm going to do today, it's going to be somewhat lighter on the science aspect, but really trying to paint for you where are we in the aging space. There's a lot of noise, some good and some not so good from my perspective, because I take the perspective that we are at the beginning of a true revolution, and that as scientists and physicians, I think we should underpromise and overdeliver. And I think what I'm going to tell you is going to be sort of colored by this. So I'm not going to tell anyone in this room that you're going to live to 900 or that we're all going to be immortal. None of this. I think, but that doesn't diminish the merit or the excitement about what we're doing, which is really a true revolution, not only in our understanding of aging, but also a changing of the way we think about medicine. So today I'm representing an institute called the Buck Institute. I'll tell you a few words, get this out of the way. We are the first freestanding research institute focused on the biology of aging. We started in 1999. Today we have 24 research groups, about 300 employees, that are all focused on understanding the biology of aging and its implication for medicine. We operate as a not-for-profit. We have, as I mentioned, 300 employees from over 30 different countries. We also function as a classical academic center. We have the good luck of living in a beautiful IMP design building, which is about 250,000 square foot, about an hour, actually an hour and a half today. That's why I got here a little late because of the traffic, just at the junction between Marin County and Sonoma. And I would love for this presentation to serve as an invitation for all of you to come and visit us and meet our scientists and learn about what we're doing in more details. Our current budget is $65 million. 50% of it is funded by the NIH, which we take as a badge of honor because it indicates that our science is recognized by our peers as solid work and not just hype. The rest is divided between corporate sponsorship, philanthropy, and an endowment. The biggest pride actually of mine is really our workforce. And the reason I'm showing you a picture of our staff and our scientists is that this is a group of people who have been doing aging research, many of them for 30 years before it actually was cool. And so we have a collective body of knowledge in terms of what aging is, mostly in simple organism models, which is the Institute was founded initially really to study the biology of aging. It turns out when I was hired, one of the message that I sold to our board who hired me was the idea that this science and this technology is ready for prime time, meaning we have to move from organismal systems into humans. And in some way, it's a great honor and a pleasure to be here with HLI because you guys are at the forefront of really bringing this technology and this knowledge to the human population and to medicine. So I usually start my talk by saying that I believe that we truly are at a historical inflection point from the standpoint of not only of society, but also from medical point of view. And the fact that these two are converging at the same time is really why you're seeing so much hype and so much noise in the press and on television and so on about what is happening to aging research. So how did we get there? Why is there so much interest in the science? First, something extraordinary has happened in the last 150 years. If you look in 1850, we lived on average to 42, which I would say most of us would not be here anymore in 1850. It's hard to imagine. And over the last 150 years, we have actually our lifespan has increased progressively about 2 years per decade. So that today we're at about 78, actually in the US, we're at 76, we've gone down with the pandemic. Most of the Western world is around 80. And so this brings up a whole series of questions of what's going to happen in the future. And if we continue progressing at the same rate, this means that by 2100, we could all live to 98, which if you think about it, and the implications in terms of society are enormous. Now, there's a lot of noise, actually, the little window here blocks my number, 150. Are we going to live to 150, which is what a number of my colleagues are saying. And so let me ask you a question. Who wants to live to 150? 1, 2, 3 people. Now, I tell you, the first time I asked this question to an audience, there were about 800 people in a huge auditorium, and I thought everybody was going to raise their hand. Actually, I had like 3 people out of 800. And the reason we only have a couple of optimists. The reason most people don't want to think about this is this picture that I just showed you of a progressive increase in lifespan is not the full picture. It's only a small part of it. And the important part that I want to highlight to you is a concept that we call the health span, which is the healthy years of life, which is shown here in orange. And what you can see is as we live older and older, the fraction of our lives that we spend afflicted by diseases is actually progressively increasing. And that means that for most of us, we associate aging with being sick. And we do this not out of the figment of our imagination. We do this out of data. We've all seen our parents, our grandparents being sick and really having a degraded quality of life. So one person said it when I asked, do you want to live to 150? It depends on what conditions. Well, under the conditions under which many of us age, it is not a very attractive proposition. And so our focus is really trying to remedy this this problem. And some people talk about immortality. I think it's frankly it doesn't belong to what we're trying to do. But immorbidity, the idea of living healthy, old, is actually not a figment of our imagination, because we think this is where a lot of the promise of our field lies today. Now, what do I mean by this health span and lifespan? We all know we've learned over the last 20 or 30 years, or actually 50 years, as we live longer and longer, there's a whole series of new diseases that have been appearing that we call the chronic diseases of aging. If you look back in 1900, most people died of infectious diseases. We had a revolution that's called the germ theory of disease, which was heralded by Pasteur and pursued by a whole series of brilliant scientists, which led to antibiotics, sanitation, sterile surgery, and all this that brought us to where we are. So think about that revolution brought on by the germ theory of disease. We think there's going to be another revolution, which is the aging theory of disease, because all of these diseases mostly did not occur. People didn't even know about them. Now that we live older, we've pushed the envelope to the point where most people who actually reach a certain age will be afflicted by one of these conditions. And what are they? Heart attack, stroke, glaucoma, macular degeneration, cancer, many forms of cancer, not all of them, osteoarthritis, osteoporosis, hip fractures, type 2 diabetes, Alzheimer's, Parkinson's, sarcopenia, which is a loss of muscle mass, and hearing loss, and the list goes on, kidney failure, and so on. So this is really what's coloring our view of aging. And the Buck Institute came up with a model, which is the so-called geroscience hypothesis, which is based on data, is the idea that aging is the major risk factor for all of these diseases. So that means if we were to understand aging, we should be able to attack these diseases as a group, not as independent occurrences. And I will come back to this later. So what makes me think, or what makes us think, that we could actually age in a very different way? And I want to point to a group that we call the centenarians. This is people among us who actually have the good fortune of living to 100. They not only live longer, on average 100, that's what defines them as centenarians, but they also age very differently in a way that they spend a much smaller fraction of their lives, shown here in red, afflicted by diseases. On average, 5%. I'm sure there will be some exceptions, some people who were sick their whole life and live to 100. On average, a centenarian spends 5 years of their lives afflicted by diseases. Now, that's very different from the rest of us, you and me. We start getting sick on average around 68. We die around 80. So we spend about 15% of our lives afflicted by diseases. So our primary goal right now is to so the delta, if you think about healthy life, which is what we are all concerned about, is from 68 to 95. That's a 30-year delta. Now, I'm showing you this number of 80 as an average lifespan that's across the whole country. I can tell you there are areas in the country where life expectancy today is 88. If you live in Marin County, or more specifically in Ross, which is an affluent community just north of Mill Valley, life expectancy is 88. That's pretty remarkable, because not everyone there, first, there's no genetic factor there, it's the environment, and not everyone is what I would call optimized in terms of their quality of life. Just so at 88 is already what they're reaching now, which has led me to say that today, if we were able to optimize the whole population, most people could expect to live to 92, 95 in relatively good health. And that by itself is an incredible message, because think about what we're doing right now at 65. And so therein lies the incredible promise of your work and our work, and hopefully our work together. So the second aspect that I want to bring is that I think we're living so that's the societal aspect. We have a rapidly aging population who's living older and older, but also living sicker and sicker. And if you look at the prediction of what this is going to mean in terms of healthcare, in terms of social security, I don't know if we have any French people in the audience. By the way, I'm not French, I'm Belgian, but I was struck by the battle that's happening right now in France fighting retirement age of 64 from 62. Now, one thing that's really remarkable of all of our social security protection system, Medicare and retirement, were generated in 1925 when average life expectancy was less than 65. So actually most people never ever benefited from this. Now we move into a situation where everybody is moving and it's going to keep growing, leading the people who have looked at the numbers to predict that we're going through a bankruptcy of the system. It's untenable. And so our work, our collective work, when I say HLI, the Buck, and other organizations, is going to be instrumental in really changing the equation that's linking aging to chronic diseases. And this is really what we are working on. So what is aging? It's probably not the right audience to ask this question, but I just want to tell you how I think about it, what we've learned in the last 20 years in terms of, in broad terms. So you don't need to be a car mechanic to know that this is an old truck. Been sitting, it's a barn find, it's been sitting there, it's rusted, its tires are busted. It's a 1940 Ford pickup truck. This is a 1940 pickup truck. The picture taken at the same time. And you don't need to be, again, a mechanic to know that these trucks, even though they have the same chronological age, they have a different biological age. And so it goes for humans. If you are above 60 and you've gone to a high school reunion, you probably will be, as I did, I was amazed to see out of all of the people that I knew when they were 18, how different people ended up looking 45 years later. Some people age well and some people don't age well. And that really is the same thing for the truck. So what defines these two trucks is the one obvious on the right was obviously in the hands of a collector who's been replacing and maintaining, and actually the truck on the right is like pretty much in the same shape as it was when it rolled off the assembly line. And so the principles that apply to the truck are exactly the same for us. We all have a chronological age and we have a biological age. That is, how well are we aging? What's our trajectory? And I'll elaborate on this later. So what really the difference, if you think about it, is a loss of maintenance, repair, and decreased resilience. And the same thing goes about all biological forms. We are in constant flux. As living organisms, we are under the toxic influences of a number of stress, gravity, oxidative stress from breathing oxygen, all the toxin in the environment, and the gamma rays coming, UV rays, and the list goes on. And we know that alteration in all of these maintenance and repair systems that we have actually play a critical role in the aging process. For example, if you're missing a DNA repair pathway, typically there are human mutants, they will live to 20, 25, and they show all the chronic diseases compressed over their first 15 years of life. So all of these mechanisms that allow us to pretty much age very slowly. If you think about it, you don't see the difference from month to month. You only see it from, when you look at pictures from 5 or 10 years ago, you see these subtle degradations. So it's actually a miracle of how well we don't age, but there's still a residual that's happening. And this is really what we are trying to understand. So I want to go through a number of what I call these breakthroughs. This was the title of my talk. Of what really is driving aging. And I want to start by asking you a very simple question. What do you think, and I'm afraid to ask this question to this audience because you're obviously highly educated, but what do you think is the relative roles of genetics, what you've inherited from your parents versus lifestyle factors in your longevity? And so I have 3 categories: predominantly lifestyle, predominantly genetics, equally lifestyle and genetics. When we say who thinks it's A? Okay. B? And C? Okay. All right. Well, whoever said A was right. But even more so than you thought, because I want to bring up a paper that was recently published. The number used to be most people. What was that?
I always tell patients that, they come to me with their 23andMe and say, look, I have this shit, I've been worried, and I always reassure them, look, ma'am, I was a molecular biologist in college. I understand DNA, and I'll tell you right now, it's 90% epigenetics and 10%.
Yes,
Mostly.
absolutely. And actually, it's even worse, 93% non-genetics. And this is a study that was just published by Calico a couple of years ago. People used to think about 20% for genetics. It turns out that there are some biases in the way it's called assortative mating, the way people choose their mates. So that gave a false estimate. 7% genetics. So you can't blame your parents. And the other thing is 93% non-genetics means it's on you. And it, not only on you, because obviously, the environment in which you are born. So my wife criticized me a little bit about this. She said, you really are blaming people for their diseases. This is not what I'm saying. You can, if you have an unhealthy lifestyle, this is what is going to happen. But we're not always in control of every aspect of our lifestyle, because obviously, right, one of the things that's happening in the country is we have a bifurcation in terms of health. We have a fraction of the population highly educated that's getting and affluent, which is getting more and more healthy, and we have the opposite in the other population. So obviously there are huge society and political issues that we will all have collectively to decide on. But to me, this is an incredibly powerful message, because meaning that you can really change the course of or how you age by changing your lifestyle. And this is what animates me to try to bring these changes to society. Not by blaming people, but by providing them the information in terms of what are the key factors that are going to be driving your aging and what can you do about it. So I like to think about these lifestyle factors in terms of buckets or pillars, and I talk about them to the lay public in terms of buckets. Like, think about them as investment funds. If you have if you're investing for the long term. All of the rules of investing successfully actually are the same as aging. Investing early pays off, diversifying pays off. And so when I think about my own aging, I try to really address every one of these key issues. And they are nutrition, physical activity or exercise, stress and sleep, human connections. And the last bucket is the science and the novel drugs that might actually be helping you to age successfully. So, and we can go back to this later, specifically in the questions, because that's typically one of the questions that I get asked all the time is, what should I do today? And there's actually a lot that you can do. And as we were talking, as David gave an example earlier, quite often there are such simple things that most people are not aware of. For example, I'll give you another little one on nutrition. I said, a lot of people drink orange juice in the morning or fruit juice thinking they're doing themselves good. And I said, you might as well drink a glass of Coca-Cola. It's not any more healthy to drink orange juice than it is Coca-Cola. So what is the fraction of the population that knows this? I would say very limited. And people are looking at me like I can see them pushing their glasses away when it's So the same thing about cereal, a bowl of cereal, commercial cereals in the morning, again, might as well drink Coca-Cola. It's not healthy. Yes?
Why not having a glass of fresh squeezed corn?
Because it's highly absorbable sugar. It's the same amount of sugar as in any soft drink. It's the same thing. And having an orange in the morning would be completely different. The juice in the orange is in these little cells. If you bite on an orange, you will feel all these little cells crumbling. And when you chew on an orange, you will only liberate maybe 20% of all the juice. The rest is absorbed and will be digested by enzymes that will digest, and so will be released very slowly. Same thing as having a baguette or any kind of bread without any fat on it. So these are the type of things that, again, talk to people. Most people are not aware. Why is this important? Because insulin signaling is the major pathway that drives aging. in all of our studies, in every animal model system, mitigating insulin secretion, insulin stimulation should be the driver. And so avoiding all the spikes in blood sugar is really one of the key things. And I believe you guys are doing CGM. That's probably the most important thing that you can do on an everyday basis to decrease inflammation, to decrease a lot of the manifestations linked to aging.
We on that thread, we've heard from a number of our clients that just wearing the CGM, the continuous glucose monitor, has really been one of the most powerful tools in changing people's life. I personally, although I'm not wearing it right now, I've been wearing it quite a bit, and it is a very, very powerful tool. And if you have that glass of orange juice, you will see your sugar go wildly high.
Crazy.
You know, and we know that, you know, as you point out, aging, dementia is all about actually the cellular level, sugar not being driven into the neurons or the muscle where it needs to be because of insulin resistance. And why do we have insulin resistance? Because we're in general overtaxed with sugar and carbs.
Yeah. Another argument for the CGM is the fact that a lot of your sugar absorption is dependent on your microbiome, and that there was a classic paper that showed that different people will respond to different carbohydrates in different ways. I might spike with the banana, and my neighbor can eat a banana and nothing will happen to him. So the whole CGM education, understanding what spikes you, is really critical. All right, breakthrough number 2. I think this could go on and on if we could. But I think it's fun to have the discussion. So as long as you're not too nervous about stopping me on time, I think we probably can continue in this conversational way. It's more fun. Breakthrough number 2 is we can change the rate of aging. And this is something that really has happened in the last 25 years. Following a number of key papers that identified unique genes that control the rate of aging and lifespan. Not only lifespan, but also health span. So I think about them as dials. If you're don't have a background in molecular biology, we've identified a whole series of dials that we can turn up or down. And by turning them up or down, we can actually change the rate of aging, change the rate of disease, and change lifespan and life expectancy. Obviously, all of this done in animal models, but there is absolutely no reason to think why this would not work in humans as well. And this is where our work lies. I want to give you an example that my lab has been involved for the last actually 25 years, is really calorie restriction. You're all familiar with calorie restriction. Is the idea if you have an animal living ad lib, starting with 100 animals, you can see they're dying on average 36 months. These are mice. You restrict calorie by 25%, 55%, 65%, and you can increase life expectancy close to 35 to 50%. I find this amazing. That tells you that, you know, we all eat too much. Obviously, you don't want to have malnutrition. If you don't eat enough, eventually you'll reach a point where you have malnutrition. But the counterpart of this is the obesity crisis that we have right now in this country, where an excess of eating will go the other direction. And this is actually one of the biggest challenge that we have as a society at this point.
That's humans. He was asking mice or humans.
This is mice. This is mice. Now, it's actually months, and yeah, it's true. It could be years. There are a group of humans who have taken it upon themselves to actually go on calorie restriction. There's something called the Calorie Restriction Society. I've met many of them. They're not a fun bunch. One of them, I was at dinner with him, and he convinced me for about 15 minutes, explaining to me how he meditates every morning eating one blueberry. And I thought, and so some colleagues have said that you know, calorie restriction might not make you live forever, but it will certainly feel that way. So that's another way to look at your longevity.
Well, another way to put it, maybe, Eric, is that, look, you know, yes, you might give yourself another 30 years by laying in the couch and eating a blueberry, but, you know, is that the goal? The goal is health span, not lifespan, right? So it really has to be balanced.
Yeah. Now, the other thing is, Calorie restriction has been shown to work in multiple organisms. So, no matter where you, including in primates, which actually suggests that it might work for humans as well. There's no reason it should not work in humans. And anybody has heard about Brian Johnson here? Yeah, I don't see too many. So Brian Johnson, I invite you to go and look at his website called Blueprint. He's a human. He actually sold Venmo as a company, and then decided to go and sort of optimize. So was overweight, typical tech guys working too much, living on Red Bull and just working late, smoking, doing everything. He found himself at 45, really in bad health, and went all the way in terms of optimizing his health. He spends about $2 million a year on optimizing his health. He has a team of 20 doctors, and they've been working at optimizing everything, including calorie restriction. And he claims he has decreased his biological age by 7 years over the last year. So, I mean, it looks like he's doing something right, except again, the lifestyle issue is not an easy one to address. So let's go back to calorie restriction. Obviously, not something that we can recommend to our patients and to people in general, but a lot of biology there. And so what the field has been doing is trying to study what are these dials that actually lie between calorie restriction and the anti-aging effect that we're seeing. And one concept is the whole idea of autophagy, which means self-eating. When you are not eating enough, you rely not only on the food coming from the outside, but also on the food that on every one of your cells. That process has really been shown to be implicated in aging mechanism. And importantly, it's regulated by a number of key protein, mTOR, AMPK, T300, which are all nutrient sensors. These are proteins that are sensing how much food is coming into the body and then triggering these protective response. And so the idea that we've come up as a field is the idea, what about if we would allow people to eat a normal amount, but fool the body to think that there's not enough nutrition by blocking mTOR, activating MPK, or blocking P300. And so many of the drugs that are being explored right now in the field are targeting these molecules. And I'm sure you've heard about rapamycin, metformin, spermidine, and there's a list that's rapidly growing. And I can give you a few examples of how some of those actually are being used in the field. Metformin is probably the one that's drawn the most attention. And this was based on, first, that it is a calorie restriction mimetic. When you take it, it elicits a response in your body that looks like a fasting response. But this study actually really triggered a lot of interest because this was a study that had nothing to do with aging, but with type 2 diabetics. And the goal of the study was to determine who is doing better of diabetics, the patients who are taking metformin or patients who are taking sulfonylurea, which is the second generation, or other therapies. And the finding was that first, this is the black is the normal controls. The controls on sulfonylurea actually did not do well, which is interesting. But those patients on metformin lived actually longer than non-diabetics. And that really threw people in for a loop. How could you live longer if you are than a non-diabetic if you have diabetes? So this really raised the question as to whether metformin might have anti-aging properties. And it's sold as glucophage. Now, I should say that very recently, this study has been criticized for a number of reasons. I won't have the time to go through, but if you're wondering why is there so much interest in metformin, this is probably based on this study and based on its properties as a calorie restriction mimetic. Obviously, we need a prospective clinical trial. This is the so-called TAME trial that Neo Barzilai and Albert Einstein have been trying to fund for a number of years. I hope it gets done because I think we should know. If you give metformin to a non-diabetic, what will happen to their risk of disease? And so this is one example where the field is trying to go. Another good example is rapamycin. The physicians in the room will recognize it as Rapamune. This is actually used as an immunosuppressant if you receive a kidney transplant. Obviously, This is a drug that one should not take lightly, at least at immunosuppressive concentration. This would bring a whole series of other risks, such as increased risk of cancer, increased risk of infectious diseases, and so on. And actually including also increased risk of metabolic abnormalities like type 2 diabetes. Now, what the field has been able to show is that if you give it at lower doses, non-immunosuppressive doses, you can increase lifespan of many animal models. And I'm giving you an example again here. This is actually a mice study where mice on rapamycin actually showed a 17% increase in lifespan. And there have been other studies showing a 35% increase in lifespan. Again, here, many humans actually are taking rapamycin experimentally. And I must say, I have dabbled with it, which is interesting. I've never felt anything. And so, you have to balance personally whether you're willing to take the risk or whether taking your chance. And this is where, again, I imagine as the clinicians working here, you probably have some patients asking you, should I take metformin? Should I take rapamycin? And for me, the issue is always, how old are you? Are you a 25-year-old? Like I've had 25-year-old guys come and tell me, should I take metformin? That's absolutely not. Because one aspect that we see with many of these anti-aging interventions, there's quite often a balance between fertility and longevity. Increased longevity quite often is associated with a decreased fertility. And for example, both rapamycin and metformin suppress testosterone. This is the only thing you need to tell your patients when they're 45 and they ask, and they're asking you for metformin. They say, you're ready to, lose your libido and this. And so anyway, just really. And it goes to the myth that is sometimes being sold by some of our colleagues is that we have these miracle medicine that are going to make you live forever. There are no medicine without side effects. I think all of the physicians in the room know this. And I think this is important for us as a field. Who are we willing to give these drugs? If you're 65 years old and you're starting to feel, some of the effects of aging, and you want to go on rapamycin, that would be a different issue for me than a 40-year-old. And so this is the future. Today we have in mice more than 100 interventions that actually can extend their health span or lifespan. And I've told you about metformin, rapamycin. Another drug that the physicians hardly will recognize is acarbose, which is also used to treat type 2 diabetes. Blocks an enzyme in your gut that digests disaccharides and so prevents absorption of sugar. There are studies in mice recently published that was associated with this showing that there's a synergy between acarbose and rapamycin. So low dose rapamycin and acarbose actually increase further life expectancy. So there's a lot happening in the field. And I think you guys are going to be at the forefront of having to decide who gets what. Does anybody get any of these drugs? In my opinion, I think giving these drugs, if you have not optimized your 5 buckets of the pillars that I described earlier, really doesn't make any sense. You only think about these drugs when we will have demonstrated that they're safe and efficacious in humans.
Eric, would you mind just expanding a little bit on the first row there, NR, because we get so many clients that ask about, NMN, NAD precursors, and do I take it? If I take it, do I take it in the morning, take it at night? Is this something I should start early 20s, 30s, 40s, or as you say, maybe later in life, if at all? And what are the downsides? Like any small molecule, it seems to me that the trouble is that you start giving sort of an end product, and then your system downregulates the enzymes that are necessary to produce it. So if you stop taking it, you're going to feel lethargic. I just wonder if you might, because David Sinclair has obviously talked a lot about this as a company that he's founded. I think that
and I mean, for full disclosure, I'm associated with 3 companies that are working either on NAD metabolism. Yeah. So I'm conflicted, but I'll tell you how I think about it. So both NR, nicotinamide riboside, and NMN are 2 precursors to NAD. And NAD is, think about it like ATP. It's a central metabolite that your body uses for all energy transfer. I tell people the analogy of NAD is the fun transporters. Think about like money in the economy is the energy. And that energy needs to be transferred from one bank to customers and so on. And you have these trucks that drive around and come, get all the money at the end. Imagine an economy where the trucks could not go, not an electronic economy, but the old economy where these trucks stopped going from store to store, picking up the money and bringing it to the bank. The whole economy would grind to a halt. That's what happened to NAD as you age. For a number of reasons, NAD levels progressively decrease during aging. And the beauty is you can remedy to this by providing either NMN or NR, which are two different precursors for NAD. They're both orally available. Now the question is, I take a little bit of NMN and a little bit of NR. David Sinclair takes a gram of NMN every day. I think when you reach these concentrations, you reach true pharmacological effect where more potential for complications. And that's the point that I'm trying to make. So if you want to mitigate the NAD decrease during aging, in some way, it's like taking vitamin D. Take a low dose, couple of 100 milligrams a day. You're certainly not going to do yourself harm, and you might actually help a little bit.
So,
now, yes.
Eric, comment a little bit about the studies that came out about the cancers.
Yes.
At the higher dosages and the neurodegenerative, how it does help when it's at lower dosages. Like, what's that fine line?
And
What are your thoughts on that?
there's no fine line. What we need is prospective, placebo-controlled clinical trials.
Right.
And I think there are a number of serious companies that are doing this. One of the ones that I'm working with is a company in France. They're doing clinical trials. And, the reason there's so much excitement about this, except for Peter Attia, who for some reason has decided they don't have any effect without any more data than the people who say that they are effective, is that we don't have the data. But in animal models, these molecules have very powerful effect. And I've been, I was one of the doubters. We did some clinical trials, for example, in loss of hearing in mice, got amazing effect. I mean, you can measure hearing objectively in a mice. This was not a figment of our imagination. So I think I would not listen either to David Sinclair or Peter Attia, and I would say, let's do the work and look at specific indications where we know NAD levels. For example, we just submitted today a paper showing that if you treat young mice with NMN, we can increase their fecundity, and we can actually increase their ovarian reserve. Remarkable. Nothing else is able to do this. So I think we're early days. A lot of the companies that are selling this as supplements, actually the FDA just forbade it. It's been taken off of Amazon. And I think we're going to need time. There are dozens of clinical trials that are ongoing, and some of those are going to hit good response.
Yes. On my take is what you were saying is, for as we age, having a little bit of a gap filler to try to repeat what you lost, I think is important with trying to get some of the benefit without actually getting the negative side effects. And also, looking at the curve of presentation, right? If someone's at higher risk for neurodegenerative disease versus someone who's got cancer, dosing is going to be very different.
Exactly. Exactly.
Eric, I really appreciate the information that you shared with us today. I wanted to know what you didn't mention anything about the statins, because in my reading about the statins, they really have a role in the senescent cell clearance and helping the macrophage get rid of the cells that are dying, especially in neurodegenerative diseases like the microglia cells. And so what is your thoughts about statins and longevity and sort of like neurodegenerative?
Yeah, I cannot speak. I mean, I know only about the statins in terms of heart disease, which is where the clinical trials have been conducted.
Right.
And I think clearly, it's a $20 billion, the statins collectively is $20 billion a year. That is based on real science. Now, the problem with the statins, and it's the same problem as every other medicine that we prescribe as physicians, is you need to give statin to 10 people to have one person benefit from it. So if you give, if you have 1 million people taking a statin, only a tenth, $100,000 or 100,000 patients are going to benefit. The other one, it's mostly not going to hurt them, but it won't have any effect. Now, why is this? It's because we cannot predict who is going to benefit and who's not going to benefit. And there comes another thing I'll talk about later, is the whole idea of personalized medicine. We need better markers. The reason we don't know who's going to benefit. We don't have the markers. But it's the same thing for pretty much every, I have the slide in my computer. Every medicine that we give has an efficacy in about 10 to 15% of patients. Because we do large clinical trials and we look at statistically significant data. So we know we have a population effect, but we don't know that we have an individual effect. So I would say statin, if you have a family history of heart disease, I think, and you're 65 and or even 50 and your cholesterol is 210, the risk is minimal unless, you develop one of the myopathies and so on. And so statins, you can think about them as, I don't really think about them as anti-aging because they don't target aging mechanism. But does that answer your question? Yeah. Yes.
So it is promising.
So that's actually, maybe I should correct what I said because you know more, you reminded me of something. The cholesterol pathway leads to the synthesis of a whole series of lipid mediators, the prostanoids, and all of these that contribute to inflammation. So there's growing evidence that the statins don't only lower cholesterol, but also inhibit and suppress inflammation. Yes. And
Eric, one last question before you move on, because we get so many questions on NAD. And this is sort of, basically kind of a statement and then a question. We know that so much of chronic age-related disease is due to protein misfolding, the inability of cells to remove misfolded proteins from, Alzheimer's with amyloid plaque and the synucleinopathies and Parkinson's with alpha-synuclein, and even diabetes type 2 with some of the amyloid type precursors there in the islet cells. And sort of the hypothesis is that as we age, we get more and more of these misfolded proteins, and these lead to really cell death and apoptosis. And that if you can, somehow keep kind of the mitochondria buzzing, so to speak, you sort of stimulate, you can stimulate the cells, whether it's the neurons or the islet cells, the pancreas, that you can help sort of remove, these misfolded proteins. So there's a Lancet article which showed that actually there's an overall 40% risk reduction in smokers to Parkinson's. Yes. And the idea is that nicotine as a stimulant, basically over the lifetime of smoking, helps your neurons, basically remove misfolded proteins. So I wonder to what extent we think of, NAD as in some ways sort of a mitochondrial stimulant in the sense like a caffeine, like a nicotine, like a creatine, or like a reduced ubiquinone or ubiquinol, that basically you're really just helping your cells become a little bit more active. They can remove misfolded proteins, but maybe the flip side of that, because we've heard this from some of our clients, is that when they take NMN or some of the NAD precursors, they almost feel like it's like a caffeine. They maybe don't sleep as well. What is your sort of comment on that overall?
I agree with everything you said.
Yeah.
And I think about, there's a lot of evidence for aging being an energy crisis.
Yeah.
And, remember I told you about maintenance. We spend, as organisms, an enormous amount of energy repairing damaged DNA, refolding unfolded protein, digesting. So all these maintenance, and actually this is the battle that living organisms have made in evolution, is always between how much energy allocation do you devote to repairing versus reproducing. And so that's why we see such an antagonism between aging and reproduction. So you can either reproduce very quickly, which takes a lot of energy, or you can actually just maintain yourself to reproduce slowly over time. So there's a lot of incredibly interesting data. And so if you talk to anybody who's 70 or 75 years old, one of the things that characterize many of them is I'm losing my appetite. And I think, they have an energy crisis. They don't know how to extract the energy, and they have less energy to devote to repair. And that's why one of the reasons why people think that aging is such an exponential, it is an exponential factor. It's not linear. So you age faster and faster, the older you get, basically. So I think when I think about my own longevity, or patients or whatever, I always think, how can you optimize this at multiple levels? And so optimizing your NAD levels is clearly, if you're 75 years old and you're in good health, or you're feeling, a lack of energy, we clearly see effects when you give people NMN at a higher dose. And quite often I tell people, take it until you feel an effect. And quite often, at 500 milligrams, people tell you, yeah, I have a second lease on life. I feel different. Now, we are also different. The same with creatine. Anybody who's lifting weight or training knows the effect of creatine.
I will say, Eric, like
Yes.
to that point, I think it's important what David was saying is that you want to start dosing or refilling that battery early on. So
Yes.
that you can sustain it. But everybody's ability to really refuel that battery versus over flooding that battery is very different.
That's
So I
key.
think that's where the importance you were mentioning about personalized medicine is,
Yeah.
is you can't overdo it though.
And then are they doing any studies comparing like to increase ATP and get the mitochondria buzzing? Are they doing any studies to look at exercise? Because obviously people who are exercising and doing strength training well into their 70s or 80s, they're so stronger than 50-year-olds.
Yes, absolutely.
So I think, how does the supplements compare to exercise? Is anyone doing a study? Because that's the best way to get our ATP mitochondria.
I agree. And
Yeah.
exercise is the most powerful anti-aging medicine that we have today, and we're going to have for the next 10 to 15 years. I tell people, don't wait for us at the back, just go to the gym.
Yeah.
And, if you think about what exercise does, what does it do? It increases your mitochondrial density. It increases the efficacy of everything that's involved in energy production. And so to me, it's not that surprising. Plus, there are all secondary effects from the muscle onto your general physiology. Your muscle affects your liver, it affects your brain, it affects everything. So I always tell people, exercise is a magical potion. It's really, you don't have to look for the Buck Institute for this to come. It's here today. And, exercisers on average live 7 to 8 years longer than most people. And what's another statistic that I find amazing is 25 minutes daily walking reduces your year-over-year risk for heart disease, cancer, Alzheimer's by 40%. 40%. So think about any medicine that we have, 25 minutes of walking every day. And, so don't ask me for metformin. I tell people, well, how much do you walk a day, or what is your exercise routine? And you don't need to do an hour a day. 30 minutes a day is already enormous. So yes, I think you're speaking to the choir here in this respect. Yes. You can't right now. And now here's another thing. I'll tell you an example. So Brian Johnson, to go back to him. So if you've never heard about him, go look at his site, Blueprint.
By the way, we caused some of his biologic aging. He was on the board of Human Longevity. So
Was
I
he?
actually know Brian from those days.
Yes.
We caused him some angst back then.
Really? And,
Yeah.
and you should see what he's done
Yeah,
now.
no, I know. I have seen his work actually. I think Newsweek, or was it? Or no, it was
Bloomberg?
yeah, Bloomberg had a
Yeah, exactly. And I met him, 3 weeks ago for the first time. We spent a whole afternoon. I first, when I met him, I thought this guy is completely nuts.
Yeah.
But the more time I spent with him, I thought he's going to be a true pioneer.
Yeah, he's like all of us. He's sort of on the bleeding edge, but you don't know if he's also on the lunatic edge. You don't know.
He's a little bit. After hearing his regimen, I thought he's a little bit on the lunatic edge. In terms of supplements, he takes like 128 supplements a day, which I think is we have a saying in French, le mieux est l'ennemi du bien. Better is the enemy of good. So there's such a thing as doing something too much. And one experiment that we did in the lab, which was quite interesting. So you take, let's say, a drug that enhances lifespan, like metformin, you give it to a mice, and then you say, okay, which of the other drugs actually synergize, and you add acarbose and you add rapamycin. And so when you do this, you find all these pairs that synergize. Then you say, okay, let's find all these pairs that synergize. Let's say acarbose and rapamycin. Now let's add metformin, or let's add another drug on top of it. In almost all cases, all of the effect went away. And actually, when you get to 4, you actually start seeing shortening of lifespan. So there is such a thing as overdoing it. And I tell, when I hear what people are taking, I think if you want to test everything, you'd be better off cycling, going one period on rapamycin and then a period on something. But taking everything at once, thinking it's going to be doing you better, I really worry about this. And I think I made that point to Brian, but I don't think it's same. And at the same time, he's still very young. He's like 50.
Right,
so that means
right.
he still has a high resilience to a toxic load,
Yeah,
which might actually go, there's studies, for example, that metformin in people above 75 actually causes problems because metformin does its action by actually blocking mitochondrial function. And so it's actually a mitochondrial poison. It blocks complex 1 in mitochondria. And that itself is sensed by the cell as a deficit in ATP and leads to overproduction of mitochondria. But, again, it might work in a 60-year-old who has the capacity to make more mitochondria. If you give it to a 75-year-old who is already at the limit, you might actually, causing you might crash them.
Yeah.
And so I think this is really, as you deal with older patients, I would be very careful in many of these interventions and just exercise caution. Breakthrough number 3, which is, I think, the part that really excites me the most because it has the biggest potential for you and for us, is I think all of these discoveries are the potential basis to reinvent how we think about medicine. And I've told you about the link between aging and diseases, and I want to review briefly sort of a classical patient experience that many of you have probably seen. So you have a patient who's 60 years old, comes in with an inaugural heart attack. First thing about traditional medicine is that person might have been considering himself relatively healthy, exerciser, but a little stress and this and that. First symptom, a heart attack, which we know in a number of people will kill you. Inaugural heart attack can be deadly. And so you go, in a medical system where someone is considered healthy from one day to almost dead the next day. And once you've had your heart attack, you are considered, someone with this very serious disease. So that's point number 1 in terms of what medicine is doing today. It doesn't really take into account the whole progression that led someone to get a heart attack. The good news is that medicine is doing an amazing job at taking care of people who have a heart attack. So that person will hopefully, be induced to change his lifestyle, do this and that, will survive, will go through a rehabilitation, and will do well, and will continue to age. And as we continue to age, remember all these risk factors for disease are exponential. So 5 years later, this person is going to come with an inaugural cancer. Again, most of what medicine does today is doesn't recognize the link between the two of them. And they will go to a cancer specialist who will treat this patient. And we're doing amazing progress with immunotherapy. So hopefully we can cure that cancer. That person now is going to survive and go, at age 80 and will come and present with symptoms of dementia. And the list goes on. The problem I have with medicine today is that it's treating all of these diseases independent occurrences. The biggest risk factor for all of them is your age. Now, the first time I said this to someone, the person said, everybody knows getting old means getting sick. And I said, yeah, everybody knows this. The same way everybody knew that apples fell from trees before Newton came. He was not the one who discovered that apple fell from trees. He was the first one to ask why. What's the link that makes the apple once it fall down to the tree? That led him to discover gravity and the universe, laws of the universe, made the connection with the planets orbiting each other. So that's where we are in terms of our understanding of disease. Why is there such a profound link between aging and all of these chronic diseases of aging? Now, the beauty, so to summarize this, if you think about our model system right now for healthcare, we call it healthcare, I think it's sick care. It's organ-based. It's based on a model of biology which dates back to Vesalius, who was one of the first, Westerner to dissect a human and to actually identify all the organs. And so we have National Institutes of Heart and Lung Disease and National Institutes of, our funding systems, our doctors. We have doctors for the lung, we have doctors for the, and none of these people actually, by the way, are talking to each other enough. And so it's reactive. We wait for people to be sick. We manage their disease quite well, and it's universal. I mean, that's what I was talking about earlier with the statins. And our vision is really, and I put the buck proudly there. I should have put HLI if I had been a little more diplomatic. But our understanding of biology and has really changed in the last 50 years to the point that instead of thinking about organs, I showed you TOR, which is mTOR, which is a pathway that really drives aging. It's not only present in the brain, it's present in the brain and the heart. So when you give rapamycin to a patient, you're actually affecting every one of these tissues. So we need to really integrate our understanding of biology into a system-based understanding. We need a much more proactive form of medicine, which will be eventually preventative, and it needs to be much more personalized. So I think this is really what excites me to be here, to work with you, to try to implement a new way of treating and preventing disease. So I want to finish with just a question. Maybe this is a question for the audience. I don't realize how late we are. 7:38. We already are late. But how can you improve your health span and longevity? And I show this picture because it's a joke, but probably not by smoking, but it's also a real picture. This patient's name is Esther, and she turned 100, and she is actually followed by, some of you might know Neil Barzilai, who has a whole cohort of centenarians in New York, and he told me he saw her for the first time. She was 102, and he said, Esther, I mean, you should consider yourself so lucky. You've got 102. You know, you're still smoking. Have you considered stopping smoking? And she looked at him. She said, honey, I've had 4 doctors before you. They all told me to stop smoking, and they're all dead. And so on this, I want to maybe close on the 5 pillars of aging, which I think should be the majority of our effort. Now, one thing I want to say about this is that, yeah, when I start talking about, people will stop me and say, well, we know what you're going to say, eat less, exercise more, sleep more, have more human connections and so on. But I know all of this, and actually most people know this, but they're not doing it. And the question to me is really how, as a field, do we transform all of this knowledge into actionable items? And for example, CGM for me is a great example. People say, well, I should not eat this, but they don't really know until you put a CGM on their arm and they look at the numbers. It did it for me. My 2 favorite fruits were dates and figs. And if you put a CGM and eat a date or a fig, you will never eat one again because it's horrible. And so same thing with orange juice, same thing with a bowl of cereal and so on. So I think we need, as a group, the biggest challenge for us is not so much to accumulate the knowledge. We know what we should be doing. Is how do you convey this in a way that's practical for people? It doesn't really help to tell people you have to exercise 7 hours a week. How? What form of exercise? So a lot of work needs to be done. More work, I would say. Everybody focuses on this because that's the easy pill. And my dystopian vision of what the Buck Institute could be, the institute that allowed the whole country to become couch potatoes forever. So that's not what we want to do. I think we should start on the first 4 and really give solid advice. But most importantly, measure it and show the people, okay, here's what you're doing to your clocks. Here's what you're doing to these numbers. You're in the right direction. And here's where you can predict to live or die, basically. So on this, I will stop here. And hopefully many of you will come and visit us and we can continue this conversation. Thank you.
Eric.